So now we're going to start looking at alternating series tests and absolute convergence. So for each of these series, we want to do a few things. We want to first identify if the series converges or diverges directly, and determine if the absolute value of it converges or diverges. And then if it does converge, determine if it's conditional or absolute. So for alternating series tests, is definitely it has to go from the terms have to alternate. You usually have a -1 to the n+1 times term here. The test is actually very similar to the nth term test, but for alternating series, if the limit as n goes to infinity of the series itself, 1 over n squared, like this, if this equals 0, then it definitely converges. Now, remember, the nth term test would only tell us if it was non-zero, it would diverge. It wouldn't tell you anything about convergence. But if the terms are alternating, a positive and a negative and a positive and a negative, then if the term without the negative, without removing the sign, if that goes to 0, then it automatically converges. And if it's greater than 0, then it diverges. Okay, so this converges. That's A. B, determine if the absolute value would be this series, just without this, and this one converges by the p-series test, right? And so what we'd say is, because the absolute value of the series converges, the thing converges absolutely. Absolutely converges, or converges absolutely is how you say. So convergence will be like if the series with the alternating sign converges, but the absolute value doesn't converge, then it converges conditionally. But this one converges absolutely, because it doesn't matter. This positive negative flipping doesn't force it to converge. Okay. So for part A, to determine whether or not the series converges, we use the alternating series test. That's just taking the nth term without the -1 here. And this equals 1/3. And because it's not equal to 0, it diverges. Okay, and then you're pretty much done, because without the absolute value sign, there's no way it can converge either. So B is still diverges. And C doesn't matter, because the answer is diverges. Once it diverges, it just diverges regardless. Because removing the absolute value sign is not going to somehow make it converge, right? Because it's alternating positive and negative. If I make all the negative numbers positive, that doesn't like improve its chance of converging, right? Like, it's just going to make the sum bigger. Now I'm going to take the limit. So for part A, the limit n goes to infinity of the term without. Okay, we look at the dominant term, so it's going to be 3n over n squared. That's 3 over n, and that's going to approach 0. So this converges because the terms themselves approach 0, and it's alternating. So that's by the alternating series test. Then without the alternating series, we're looking at this series with the absolute value, the 3n plus 5 over n squared minus 3n plus 1. The simplest way to tell convergence of this one when you have polynomials is to look at the limit comparison test. And you're going to compare it to 1 over n. Because here I have an n on the top and n squared on the bottom. So it looks like n over n squared, which is 1 over n. So this is going to be 1 over n times n squared minus 3n plus 1 over 3n plus 5. The top has an n squared. The bottom's going to have a 3n squared. So it's going to be n squared over 3n squared, which is 1/3. And because this is a finite value, it's between 0 and infinity, they both converge or both diverge. In this case, they both diverge, because 1 over n is the harmonic series, or by the p-series test, this diverges. So C, then, the answer is because it only converges with the -1 to the n+1 part, that means it converges conditionally. See, if the absolute value of the sequence converged, then it would converge absolutely, but now it converges conditionally. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.